Good afternoon, I'm Diarmuid McDonnell. I'm a lecturer in social sciences at the University of the West of Scotland, and in this learning resource I'm going to show you how you can collect data from the web, and this is a technique more commonly known as web scraping. In this first video we're going to look at the fundamentals of this social research method. In particular we're going to look at the value. It's a key question: why should we be interested as social scientists in collecting data from the web? I'm then going to outline the logic, so the kind of core steps that every time you're looking to scrape data from the web, you will follow these steps. And then we will implement the logic as well and look how we can achieve it ourselves. The first thing I'll do, before going into what it is as a technique, is actually demonstrate that I know what I am talking about. So here I have a programming script that looks to collect data from the web. So currently I'm working on a project that is interested in the impact of the pandemic on charitable organisations. So one of the countries I'm interested in is Australia, which has quite a well-developed charity sector in place. Now what I'm interested in is collecting information on the numbers of charities that are formed in a given month. So these are new charities that come into being, and I'm also interested in the number of charities that no longer exist. So these are charities that maybe have completely become insolvent, do not have the financial capacity to operate, maybe they've merged with a different organisation, maybe they've continued to operate but they've renounced their charitable status and they're operating as companies or private businesses from now on. Now to get the first piece of information, the number of new charities registered, I can do that in a very familiar way. Now I can download a data file from the charity regulator and I can extract the registration field and the date field, and I can do the analysis that I need. What's difficult is to get information on charities that no longer exist. That's not contained in the data file. I can't simply download it manually by going to the website or any other usual means of doing so. But what I can do is I can view this information on the regulator's website. So using their search tool, I can see a list of different statuses. So I can see all the charities that continue to operate as organisations. Maybe they're social enterprises or businesses now, but they no longer want to be charities. So I can use the regulator's website and I can find out how many of these charities there are. So here we have the list. So again, this is all publicly available information. I can get the name of the organisation, its charity status, and a link to its webpage on the regulator's website. And it's on that web page where I get the information that I need. As you can see, this is its cancellation date. So this is the date this organisation continued operating but no longer existed as a charity. So what I needed was a programming script that went to the regulator's website, collected that tabular information and outputted it into a file that then I can use in my research. I'll go into the detail of how this programming script is constructed in a later video. For now, I'm just going to set it running, continue with the presentation, and hopefully in 5 or 10 minutes time show you that it has actually worked. So let's return to the fundamentals of web scraping. So how can we define it? Well, the first thing to say is that it is a computational technique for capturing or storing or extracting data that's stored on a web page. Now, computational is the obvious but key word here. You can manually visit a web page just like I showed you right there. We can use our mouse or we can use our keyboard and we can select the information that we want. We can right click, we can copy and paste, we can right click on an image and say save image as, etc. So we can manually download or extract data from web pages. And oftentimes it can be simpler. If you only need a little bit of information infrequently, you can simply do a manual extraction. But of course there's some very obvious downsides when it comes to accuracy and the kind of labour resource needed to collect larger, more frequently updated social science data sets. How do we do it? Well, we generally implement it using a programming script, just like the one I showed you, which is written in the Python language. But there are software solutions that you can use also. So Google Chrome has a means of scraping a web page, so you can use your browser to do it. Microsoft Excel, I think, has some functionality that allows you to scrape web pages, and there are specific software packages that you can use also. I'm generally in favor of writing programming scripts. I think you get additional flexibility and kind of specificity of what you want to do. I think there are intellectual benefits that accrue also from learning a programming language as a social scientist, and there are some other reasons why I think it's worthwhile also. But the ultimate aim, we're social scientists, it's to collect social research data, and whether you do it using a programming script, whether you do it manually, etc., that's of course up to you. What I would say is the programmatic approach is actually relatively simple. It may seem daunting at the outset, but actually it's a very mature method, web scraping. There's lots of documentation, lots of examples, and lots of help out there that will get you up and running very quickly. So why should we do it? This is a fundamental question. As social scientists, maybe it's interesting, maybe you get a kick out of it, I certainly do, but why do we do it for our research purposes? Well, the first thing to say is maybe an obvious point, but it should be stated. Web pages are an incredibly rich and important source of publicly available information on a whole variety of social phenomena of interest. My particular area, as I've just said, is charitable organisations. The data files and the kind of data resources that are available are increasing in quality and in terms of volume, but there's still quite a lot of information, as we've seen in my example just there, that can only be accessed through web scraping. Now I can do it manually, I can take an incredible amount of time, but the project I'm doing needs monthly snapshots of the number of new charities and the number of disappeared charities, and web scraping provides a very accurate and reliable way of doing so. When you think of the variety of information that web pages can hold, I mean there's a whole host of different data types. We've got files, we've got text, we've got photos, videos, we've got lists like I've just shown you, tables of information that we might be interested in. And web scraping can be used to collect all of those different data types. So it's not just for cutting and pasting, in an automatic way from a web page, and we can use it to request files and download them to our machines. It's a very flexible method in that sense. And once collected, the data that we think is of interest and is really rich and varied, we can kind of reshape it into the formats we need for analysis. Typically, I'm a quantitative researcher, so I use Stata, and as you'll see with the example I've just been showing you, it's going to spit out a nice CSV file that I can import nice and easy into Stata for analysis. So what's the logic? So how do we actually go about implementing this research method? Well, basically there's two kind of stages. There's things we need to know and there's things we need to do. So the first thing we need to know is the location where the web page can be accessed. And this is maybe more commonly known as the URL or the web address or the link. Different interchangeable terms can be used, but all of those things represent the location on the web where that web page is actually stored. So for example, the BBC homepage can be found at that following URL, https://bbc.co.uk, and that's the location of the BBC website on the World Wide Web. So once we know the location of the actual web page we need, then we need to find the location of the information on that web page. Now, web pages, you'll be very glad to hear, follow a very standardized and interpretable structure. So it's not just a wash of text and programming code. Web pages are hierarchical. They use tags to identify different types of information on the web page, and we can use that to our advantage to locate the information we need and then to actually extract it. So once we know those two critical pieces of information, we can move on to the fun bit, the doing, the actual scraping of data. So the first thing we do is we need to actually request that web page. We do that manually by opening a browser, for me Google Chrome. You type in the address or the link or the URL and you press enter or you press the button, and your browser requests the web page and returns the contents to you so you can view it. So we can also mimic that process, or we can conduct that process using a programming language. Once we've requested the web page, we then need to parse, or we need to understand the structure of the web page, so then we can start picking out the bits of information that we need. In essence, this is just basically telling, in my case, Python, that what we've requested is a web page, it's structured like a web page, and take that into account as we move forward. So once we understand the structure of the web page, then we can start picking out the bits of information that we need or that we're interested in. And then we can write that information to a file so we can use it for our analysis later. So 6 kind of key bits, or 6 elements of logic to web scraping. 2 relate to knowledge that we need, and 4 relate to practices that we need to engage in. So what would be the value of all of that kind of process? So really, as I said before, it's a very mature method. It's got lots of established packages. What I've been using, what we'll use going forward in this learning resource, is the requests module and the beautiful soup module in the Python programming language. There's lots of examples, lots of help available. You're not starting from scratch. There's plenty of available help. If we use computational rather than a manual approach, we get the ability to schedule or automate our data collection activities. As I've said previously, what I do is I set this programming script running once a month, on the 28th of every month. I have a server, so I have my own computer in the cloud. It runs on that, all the data gets downloaded there, and then once a month I download to my machine, I import it into Stata, and I produce the analysis that I need. And again, the richness of the information and its variety as well that you can find on web pages, I think it's a point worth repeating again and again. There's an enormous amount of digital information relating to social phenomena that if only we could access in a very reliable and accurate way, we can do so much more with as social scientists. So it can be a very accurate and reliable data collection method, and a very useful part of your toolkit as a social science researcher. So I've been evangelizing about this method so far, but of course it has a couple of limitations that need to be borne in mind. The first is the information that you request. It tends to be updated quite frequently. Now there are some web pages that never really experience updates or changes. But again, going back to maybe the BBC website, that changes every couple of minutes, never mind every hour or every day. So the information on that changes very frequently. If the information changes, then maybe the structure of the web page changes, which means your programming script can't find the tag or the element on the web page it's looking for, then your script breaks. Now there's ways of improving your script so that it doesn't break when it encounters changes, but it does mean that there's quite a bit of manual checking on your part of the web page you're scraping every so often to check that it looks the way you expect it to look. And that should be bear in mind if you share your code as well, that you have a responsibility to maintain it so that it works with future versions of web pages. Some websites are advanced enough that they can block or kind of slow down or throttle the scraping that you're conducting. For example, the Amazon website, it's not possible to scrape price and product information. It's clever enough, it knows to block automatic attempts to download information from the amazon.co.uk website. That's a big example, but there are plenty. It's not a very, I say advanced, but it's not actually a very uncommon technique by websites. You may be surprised which ones can actually stop you or slow you down in your web scraping activities. Web scraping, and of course any kind of computational work that you do, is dependent on your computing setup. Web scraping is very possible to do on standard desktops and laptops. You don't need lots of memory, for example. It's not too difficult to set up Python on your laptop. That's something we can demonstrate, but it still should be borne in mind. So Python itself gets updated every so often. The packages that you use to scrape websites, that gets updated every so often, and this all needs to be taken into consideration, and updates need to be made to your laptop or desktop or whatever that you're using. And of course there are some ethical and legal implications of web scraping. We'll cover those in the final video. You don't need to be too scared of the legal kind of ramifications, but you do need to bear in mind that it's not a free-for-all, that just because the information can be viewed publicly does not mean you have a right to automatically or computationally scrape that data or to use it for whatever purpose you deem necessary. So why have I been collecting that Australian data, returning to my example that I showed you earlier? Well, this is what I want to get at. So this is the analytical output I'm interested in. So I'm calling these charity removals. So that's an organisation that for whatever reason no longer operates as a charity. I'm interested in these 7 jurisdictions globally, the 3 UK jurisdictions, the USA and Canada, and New Zealand and Australia. So the reason I want to collect data on charities in Australia that no longer exist is I want to calculate, well, is 2020 significantly different than previous years when it comes to disappearing or removed charities. So we can see in Scotland that 2020 was an untypical year. It's nearly 2 standard deviations below the average. So there's an average amount of deregistrations that we would expect, and 2020 was considerably less than that. And it's not quite the case for Australia. In fact, yeah, there are fewer charities deregistered in 2020 than what we would expect, but it's not so low. It's not even 1 standard deviation below what we would expect. But that's the use to which I am putting the data that I've been collecting. Can I prove that it worked? Well, let's go back to the programming script. This is a little output window, so I'm asking the programming script to print some relevant information to the screen. It's telling me it's requesting different URLs, different page numbers. We'll get into what all that means in future videos. But here is the output. So here's today's date and today's time, just to show you that the programming script has created this file. It's not something I've done in the background. We can open it up. Let's see if it's actually scraped the information that we need. And voila, yes, it has worked. Excellent. So the table we were looking at previously, this table here, I have now basically scraped it and converted it into a data file that I can now import into Stata and use for my analysis. So here you go. Yeah, the Astronomical Society of Tasmania, which I think is on a different list, and that charity has its charity status voluntarily revoked. It's no longer entitled to be a charity. What I do with the broader programming script, because that was just a snippet, is I go to every charity's webpage and I scrape what date it was registered and what date it was deregistered as well. And that's how we conduct a web scraping piece of data collection for social science purposes. In the next video, we're going to get into a more in-depth practical demonstration, and it's something you can use as well on your own machine. There's no downloading software on your machine. Everything we can do through the cloud. So I'd encourage you to join in with me as well. Excellent. So see you in the next